How can engineers solve peripheral interfacing debugging problems? Imagine connecting a new sensor or display to a microcontroller, only to find it refuses to communicate. Troubleshooting these issues can seem tricky, but there are clear steps to fix them. When engineers face peripheral interfacing bugs, they start by understanding the problem. They check if signals are reaching the device correctly and if the configuration matches the peripheral's requirements. Using a multimeter or an oscilloscope helps verify voltage levels and signal waveforms on the physical pins. For example, if a UART communication is not working, they look for proper voltage levels and clean waveforms to rule out electrical noise or wiring faults. Next, engineers use hardware debugging tools like JTAG or serial wire debug interfaces. These allow them to connect the microcontroller to a computer and control program execution. With debugger software, they can set breakpoints, step through code, and watch register values change in real time. This helps identify if the code is correctly configuring the peripheral registers or if some commands are missing. For example, if an I2°C device isn't responding, they can check if the clock line is active and if the correct device address is being sent. Software logging is another simple but effective method. Engineers insert print statements or send messages over serial interfaces to track the program flow. This can reveal if the code is reaching the part where the peripheral is initialized or if some condition is preventing proper setup. Sometimes, timing issues cause problems. Using real-time trace features, engineers can see the sequence of events, including interrupts and function calls, to find where delays or conflicts occur. Electrical issues are common, especially at high speeds. Engineers ensure signal integrity by keeping cables short, shielding them from noise, and adding termination resistors if needed. They also double-check pin assignments and initialization routines to avoid reconfiguring debug pins accidentally. If debug access is lost, recovery modes or bootloaders can help restore control. Configuring peripherals correctly is key. Engineers verify that clock sources are enabled, data formats match, and handshaking signals are properly set up. For example, setting the right baud rate for UART or ensuring the SPI clock polarity and phase match the peripheral's specifications. They also confirm that interrupts are enabled and prioritized correctly so the microcontroller can handle incoming data without missing events. In troubleshooting, a step-by-step approach works best. First, confirm power and ground connections. Then, check physical signals with hardware tools. Next, use debugging interfaces to inspect register states and program flow. Documenting pin assignments and configuration settings helps prevent confusion. If issues persist, testing with known good peripherals or simplified code can isolate the problem. Engineers solve peripheral interfacing bugs by combining hardware checks, software debugging, and careful configuration. They verify electrical signals, control program execution with debuggers, and analyze real-time data streams. This systematic process helps identify whether the problem is electrical, software, or configuration related. By following these steps, engineers can quickly pinpoint issues and get peripherals working reliably in embedded systems.